Hello, so welcome you all. Today we'll discuss about haloalkane and haloarenes. So first we'll discuss about haloalkanes. Now, if you see this haloalkane, so this word constitutes of two parts. One is halo, another one is alkane. So what is halo? Halo is the halogen atoms such as fluorine, chlorine, bromine, iodine. Okay, and alkane is like that. The general formula of alkane is CnH2n plus 2, right? So if you know that if the number of n can varies from 1 to like any numbers, methane, ethane, propane, butane, these are the alkanes. Now if you see, if I have one alkane such as ethane, CH3, CH2, and there is one H. Now if I substitute this hydrogen with the chlorine, so it will be like this way: CH3, CH2, and then Cl. This is what it is, like haloalkane, right? This is ethyl chlorine, right? So this is the example of a haloalkane. Here this stands for the halogen atom, and this is the alkyl part, right? So now we'll see like what is called haloarenes, right? In the haloarene, the common word between the haloalkane and the haloarene is that halo, right? That means there should be some halogen atom, and arene stands for the aromatic ring. Let's say we have one benzene ring, and we have a basically this is called chlorobenzene, right? So the any of the hydrogen of any aromatic system, if it is substituted with halogen atom or atoms, so those are called haloarenes. Now on example we'll see. Carefully, if you notice this one, do you think this is a haloarene? The answer is no, because see here this is not the aromatic ring, so this is not haloarenes. Instead, this is one of the haloalkanes. Okay, now we'll see what are the types of haloalkanes. Okay, first is that primary, secondary, and tertiary. Now let's say one example: CH3, CH2, Cl. This is our guest halogen, and this is the host carbon atom. Okay, this is for example we are taking like this, that this is the like guest and this is the host. Now how we'll understand this one is primary, that is 1 degree, or this one is 2 degree, or this one is 3 degree. The thing is that we have to consider the guest halogen atom connected to the carbon atom, how that carbon atom is connected to how many number of carbons. So in this case, if you see the carbon, the host carbon is connected to only one carbon atom. So this is basically 1 degree. Now if you see another example, so in this case, if you notice carefully, the host carbon containing 2 other carbons, right? So this one it will be 2 degree haloalkanes. But this case, if you see, the host carbon which is containing 3 other carbons, right? So this one will name as 3 degree haloalkanes, right? Now these haloalkanes can be like monosubstituted, disubstituted, or tri or tetra substituted, right? Like monosubstituted, we have already seen the example CH3 CH2 Cl, right? methyl chloride, anything it can be. So in the disubstituted, there are two types. One is vicinal and another one is geminal. Carefully you have to see what is called vicinal and what is called geminal. So now if you see, this is like that, CH3 CH. So see, this is called vicinal chlorines. This is coming under the dichloro. This is basically the butane, and 2-chlorine it is substituting, but this is called vicinal chlorine because these chlorines are substituting to the nearby carbons, right? They are basically holding to the nearby carbons. But in case of the geminal, how it looks like? CH3C. Now see, this is called geminal. Okay. So this is vicinal chlorine. This is geminal chlorine. Now we'll see the example of tri-substituted haloalkanes. This is very well-known chloroform is there, right? CH Cl3. There are bromoform also, CHBr3. There are iodoform also, CHI3. So these are the tri-substituted, right? Now I'll see for the tetra-substituted. Tetra-substituted examples are like CCl4. So the parent compound is CH4. So there, if we are substituting 4 hydrogen with the 4 chlorine, this is giving tetrachloromethane. We can have tetrabromomethanes also, tetraiodomethanes also. So these are the examples of mono, di, tri, and tetra haloalkanes. Now we'll see there are another types of this haloalkanes. Okay, so now if you have like this CH3 CH, okay, so this case the chlorine atom which is directly connected to the carbon, which is the part of the double bond, so this is called vinyl chloride. Okay, another can be there CH3 CH double bond CH. Here is a CH2 and this is Cl. This case you see this host carbon that is connected to the another carbon which is a part of the that is basically the part of the another double bond. So in this case, this is called allylic chloride. Okay. So in the haloarenes also there are like we have this is simple haloarene. This is called bromobenzene. But there are another kind of these things. It is there. It is called CH2 pair. So this is called benzyl bromide. Okay. If the bromine is connected to this host carbon, which is a part of which is basically conjugated to the another aromatic ring, that time we'll call this one as the benzylic. Okay, benzylic bromide. Now we'll see the this what is that called like sp3 haloalkanes, sp2 haloalkanes, right? sp3 already we have seen CH3 CH2 Cl, right? So here how we'll understand this is sp3 haloalkane or not. We have to check that the host carbon is having how many number of sigma bonds. If there are 4 sigma bonds, then it will be sp3. If there are 3 sigma bonds, then the hybridization will be sp2. If there are 2 sigma bonds, the hybridization will be sp. Now we can count this one, right? The carbon atom, the host carbon, which is like where the halogen is connected. So here you see this carbon is having 4 sigma bonds. So this one it will be sp3, right? This is sp3 haloalkanes. Now this also can be there, CH3. Now this carbon atom, if you calculate the total number of sigma bond, this is double bond is there. So one will be the sigma, the another will be pi bond, right? So from this side one sigma bond with another hydrogen, there is a one sigma bond, 1, 2 and 3. So the number of total sigma bond it is 3, and we know for the 3 sigma bond will have sp2 hybridization, right? Now this can be like this also, CH3C triple bond CCl. So here I think you already can understood that among these 3 bond only one is the sigma, remaining 2 is the pi bond. So if I am asking you what the total number of sigma bond, you will obviously tell that there are 2 sigma bond. This is 1 sigma bond, this is 1 sigma bond, and so if there are 2 sigma bond, this will be sp hybridized. The carbon will be sp hybridized. Okay. So now we understood how to get the hybridization of these carbons, of these haloalkanes. Now we'll see how we'll name them, right? What is the rule for naming these haloalkanes? We'll start with the very simple haloalkanes, such as like that, CH3, CH2, CH2, CH2Cl. See, we already have learned that for the naming this kind of carbon chains, we have to find out the longest carbon chain, right? And here what we have to remember is that the halogen atom should get the lowest number, right? So we can have the 2 way of numbering, 1, 2, 3, 4. Another way is that 1, 2, 3, 4. So in which way the chlorine will get the lowest numbering? If we are going from right to left, right? This is the way. If this way we are going. So what will be the IUPAC name for this one? This is basically 1-chlorobutane, because the total number of carbon is 4 and the chloro it is there in the 1 position. So it will be chlorobutane or 1-chlorobutane. Okay, I hope that you have understood these things. Now we'll see the another example. See, in this case we have geminal chlorine. I already have discussed that this is basically the dichloro substitution, right? And this is in the geminal position. Now we need to do the numbering, and in the numbering we need to find out the longest carbon chain wherever our this chloro substitution should get the lowest number, right? So we should start from this side, 1, 2, 3 and 4. So the IUPAC name for this one, it will be 2,2-dichlorobutane. Right? So this is the numbering. Now we'll see for other cases. If you have different kind of halo substitution, such as like that, CH3, CH, right? So here you see there are 2 different halogen atoms are there. One is fluorine, another one is chlorine. Now we'll think that in which way then we have to number, right? So here we have to think about alphabetically who comes first, fluorine or chlorine, right? Chlorine starts from C, fluorine starts from F, right? So C comes first, right, in the alphabetically. So we need to name these things such as chlorine should get the lowest number. We'll check what are the possibilities. 1, 2, 3, 4, 5, 6. Right? This is one. Another way is that 1, 2, 3, 4, 5, 6. Right? So here you can understand that if we are going from right to left, chlorine, which will get the 3 position, right? So our and 3 position, fluorine will get the 5, right? So the name will be 3 chloro, 5 fluoro, and there are 6 carbon atoms, right? So it will be hexane. So in this way we need to do the IPAC nomenclature. So these are the class for the general introduction for haloalkanes, and also it's a very brief introduction about haloarenes, and we learned about the different types of haloalkanes, their names, how will I identify them, and also the nomenclature, how we can name them, right? In the next class we'll learn how we'll synthesize them, and after synthesis our next class that what is the application, right? So there we'll talk about like what are the reaction they are basically performing and all those things. I hope you have understood this class. Thank you very much.